This is the 20,000 volt Jacob's ladder and I built it to celebrate 90,000 views. The Jacob's ladder is actually built and powered by flyback transformer throwing over 20,000 volts into the air, and honestly I really don't think this will actually work, but it actually did. Do have to stay to the end and let's build this shit. Also, you really need to understand the internal working process before it actually comes to life. Now, this flyback driver uses two MOSFETs in the push-pull configuration. They switch the primary winding rapidly, creating a changing magnetic field that induces a much higher voltage in the secondary coil. Now, the gate to source Zener diode, which you actually see there, protects the MOSFET gate from exceeding voltage. Like from exceeding the particular voltage actually goes to the MOSFET. While the gate to source resistor, which you can actually see right there, controller actually holds the gate voltage and actually drain the MOSFET and make sure the MOSFET actually turns off well. Also, the 470 ohms resistor actually limit the amount of voltage actually goes to the MOSFET, and yeah, that is the importance of that. Now finally, the inductor. Now what is the use of the inductor? The inductor actually helps to smooth and release charge into the LC tank circuit and to also avoid energy from going backwards into the DC power supply, which is connected. And also, I didn't really explain the diode, which is connected to the gate of the MOSFET. In my case, the 1N4148 diode is actually a fast switching diode. It actually helps to turn off MOSFET 2 if MOSFET 1 is actually turned on, and the other diode actually helps to turn off MOSFET 1 if MOSFET 2 is actually turned on. So that's the importance of this diode. You can use a much higher voltage diode to actually keep your circuit working properly. And let's go into the build. Alright, in this part I'm going to be explaining to you the driver circuit which I'm actually using with the Jacob's ladder and the component which is actually associated with it. Now the first important component which I actually use is actually the MOSFET. Basically using the RL260 N-channel MOSFET in this driver circuit. Each gate of this MOSFET is actually connected to a 470 ohms resistor. Yeah, the 470 ohms resistor is actually connected to each of gate of the MOSFET. Also using a 1N4148 diode. Yeah, this is actually a fast recovery diode. Basically the one I actually use actually 100 volt, but it's meant for you to use a 400 volt type of diode to be on the safer side. Now another important fact which I also want to tell you is about the Zener diode. Yeah, in the circuit right here you can see that there's actually a Zener diode, basically a 12 volt Zener diode, but in my final circuit I really didn't put a Zener diode because I really don't have it. It's important for you to put it and to keep your MOSFET safe and to avoid large current to flow through the gate of the MOSFET, thereby killing your MOSFET in a second. Final parts are actually the capacitors, the pull down resistor which is actually connected from the gate of each MOSFET to the ground, and the inductor. Also moving over to the primary winding, actually the primary winding winded on the core of the flyback transformer. It's actually a total of 10 tons, 5 tons on each side, but my final tons was actually 4 on 6. But yeah, 10 ton is enough, and maybe less than 10 ton we will actually guarantee much higher voltage at the flyback, but will draw more power. You should know that. And let's quickly go into the soldering. Now basically I was thinking of connecting everything on the breadboard, but I got a bunch on the breadboard, and yeah, this circuit actually draws a lot of amps, so you need to solder it immediately to a perf board or a vary board to keep your things safe and sound, and be sure to use thick wires to do that. Now for the soldering process, we are going to be using this flux, the lead, and the soldering iron. First off, we're going to be painting a little bit of solder on our solder tip and connecting our perf board to the stand, and let's solder, chat. Alright, soldering complete. This is the work and this is the final result. Not that nice, but yeah, still good. Let's move on. Alright, we're also going to be checking through the board if there's actually any joint or any incorrect circuit. And yeah, alright, we are done with the circuit right here, and basically I've shown you before. This is the ZVS circuit and this is the flyback transformer. And also what I wanted to show you is the Jacob's ladder. Yeah, it's not really nice though, and basically I'm not really supposed to make the Jacob's ladder on the cock right here, because basically I want this metal right here. This is actually copper, I want this metal right here to get really hot, and as the metal is getting hot, so as the Jacob's ladder is actually working properly, because there's going to be sparks right here, and that sparks I want it to like flow to the top. And the reason it flows to the top is that as the air around it actually gets hot, it actually pushes the sparks upward, thereby moving to a colder air, and that is why it formed like a Jacob ladder. Anyways, I really don't have a lead-acid battery to test it out, but I have this laptop battery right here, and I hope it's supplied the voltage which I need. Total voltage when it's filled is actually like 12.6 volt, and actually 4400 mAh. But firstly, before I connect it to the Jacob's ladder, let's just test the output voltage and show you the sparks which is being generated versus when I'm connecting it to my PSU versus the battery, and let's see. Testing it first with my PSU. Let's see the result. I'm gonna ramping the voltage up to 12 volts. This is basically where the sparks is gonna be coming out from. So let's test it out. Connecting in 3, 2, 1. Oh my days! All right. So turn on the light. All right. Gonna turn off the entire light. Alright, you can see that. That is one magnificent prophecy. Okay, basically that is drawing about 3 amps, and I set it to around 12 volts, but the voltage actually tripping down because it's actually reaching its maximum point close to 5 amps when I try to act through the flyback transformer. But that is a huge spark. I guess it starts acting around 2 inch, right? 2 inch, yeah, because around this area it starts arcing. But I'm going to turn it on again. I'm going to show you the watt which is drawing from the PSU, like so. Turn it on. You can see that. You can see that it's drawing around 5 amps, and the voltage drops to 11.4. So a battery is the best. I was basically also thinking of adding this fan at the top of the heatsink because the MOSFET are really getting hot, so I need to put a fan that will cool it down. This fan I actually made in my last video to cool down my peltier modules. Alright, we set everything up. This is the Jacob's ladder, my mini Jacob's ladder actually. So let's power it up and let's hope for the best. 3, 2, 1. Oh, smoke. All right, I just noticed that there's a kind of breakage in the circuit board because of the lot of amps which actually joined. But yeah, it's all done. I soldered the back. This is my Jacob's ladder. Let's see how it is. I'm gonna adjust it a little bit like so. All right, come on. Oh shoot, it's drawing a lot of power though. The whole wires are beefing up. Oh my days, and the heatsink is getting so hot. The fan is helping though. Okay, I think the spark is unable to go up. I don't know why. Come on. Alright, all set. Let's test it out first with the light. And I'm gonna use the straw to blow it up. Fuck, come on, walk, Chad. Basically, it was only working, it was only climbing a little bit up when I blew through the Jacob's ladder, and basically it's not going up all its own, and maybe not a big deal though. It finally worked. Oh my god, it's really getting hot. Damn. just want to say thank you very much for watching this video to the ending. It's really meant a lot to me. Hope you understand everything I did, and I'm gonna give a kind of a discount on my Patreon. I'm gonna be putting the promo code on the comment section to celebrate 90,000 views on my channel. Put in the code on my Patreon and you can join for free without paying any dime, although you can still join for free. Thank you. Let's go to the conclusions.
Alright, just want to say thank you very much for watching the video to the ending. I hope you learned something new, and you just have to be careful with this kind of project. It's really dangerous and owner tricks, and if you're trying to replicate my project, you really need to be professional, and you need to be careful so that you don't get hurt or get maybe on a life yourself or stuff like that. But anyways, be careful with this kind of high voltage generators. They're really dangerous, and that is why I avoided the 2000 micro ohm transformer project, but I will intend to make it in the future. Anyways, thank you very much for watching. Subscribe and support me on Patreon if you like what I do. Join for free. I'll see you guys in the next one. Peace.